The future of cars is no longer just about speed, design, or even luxury. It has become a battle of ideas. On one side, the world is pushing hard toward full electrification, where vehicles are powered only by batteries and charged through an expanding global network. On the other side, a quieter but equally determined approach is trying to redefine that future in a more flexible way. And right in the middle of this shift, Mazda has once again surprised the industry by refusing to follow the expected path. While most automakers are racing to produce fully electric lineups, Mazda has taken a step back and asked a different question. What if the transition to electric mobility does not need to be absolute? What if the real solution is not abandoning combustion engines overnight, but reinventing how they work within a modern system? That question led to the revival of one of the most unusual engines in automotive history, the Rotary engine. But this time, it is no longer the loud, inefficient technology people once criticized. It has been re-engineered into something far more intelligent, efficient, and purpose-driven, instead of powering the wheels directly. The modern Rotary engine now plays a supporting role. It works as a compact generator inside a hybrid system, producing electricity that feeds an electric motor. The driving experience itself remains fully electric and feels smooth, silent, and responsive, but the energy behind it comes from a flexible combination of fuel and electricity. This setup allows the car to avoid one of the biggest challenges in the EV world today: dependency on charging infrastructure. This is where the conversation starts to change. While companies like Tesla and BYD continue to push the limits of battery range and charging speed, Mazda is focusing on something different: freedom of movement, without planning every journey around a charging station. In this system, fuel is no longer the primary driving force, but it becomes a backup energy source that keeps the electric system alive when needed. The result is a driving experience that feels like an EV, but behaves like a self-sustaining hybrid machine. At the core of this idea is range extension, but not in the traditional sense. The Rotary engine is small, lightweight, and designed to operate at optimal efficiency levels rather than constantly fluctuating like conventional engines. It activates only when the battery needs support, generating electricity at a steady and controlled rate. This means the car can maintain long-distance capability without requiring long charging stops. For many drivers, especially in regions where charging networks are still developing, this becomes a practical advantage rather than just a technological experiment inside the cabin. The experience is deliberately engineered to feel seamless. There is no dramatic switch between power sources that the driver needs to manage. No complex decisions. No visible disruption in performance. The system continuously balances energy flow in the background, allowing the driver to focus entirely on the road. Acceleration remains instant thanks to the electric motor, while the Rotary generator quietly ensures the battery never runs dry under normal driving conditions. But beyond the engineering, what makes this shift interesting is the philosophy behind it. Mazda has never been a company that chases trends aggressively. Instead, it often focuses on refining driving feel, balance, and emotional connection. This approach reflects a belief that cars are not just machines for transportation, but experiences that should feel natural and intuitive. Even in this hybrid evolution, that philosophy remains intact. The goal is not to overwhelm the driver with technology, but to remove friction from the act of driving itself. Meanwhile, the global industry continues to move forward with different strategies. Pure electric manufacturers are betting heavily on battery innovation, faster charging times, and software-driven ecosystems. Governments in many regions are also supporting this shift through regulations and incentives. Yet the transition is not uniform across the world. Infrastructure gaps, energy costs, and long-distance travel needs still create challenges in many markets. This is exactly where hybrid systems like Mazda's begin to gain relevance again. The real debate is no longer about whether electric cars are the future. That part is already in motion. The real question is how quickly and how uniformly that future can be achieved across different regions and lifestyles. Mazda's approach suggests that the transition may not be a single leap, but a layered evolution where multiple technologies coexist for a longer period than originally expected. And that is what makes this moment important. It is not just about a new engine design or a clever hybrid system. It is about a shift in thinking, A reminder that technological progress does not always move in a straight line. Sometimes it bends, adapts, and finds middle paths that are not immediately obvious, but become essential when viewed from a global perspective. In that sense, Mazda is not trying to replace the electric revolution. It is trying to reshape how smoothly the world transitions into it. As this idea starts to take shape in the real world, it begins to challenge one of the strongest assumptions in modern automotive history, that the transition to electric vehicles must be fast, total, and irreversible. For years, the industry narrative has been simple. Batteries will improve, charging networks will expand, and internal combustion will gradually disappear. But systems like Mazda's range extender hybrid introduce a more complex reality, where transition is not a straight line, but a long, uneven process shaped by geography, infrastructure, and consumer behavior. In practice, this means the global shift to electrification is happening at very different speeds depending on where you look. In highly developed urban regions, full electric vehicles are becoming more practical every year. But in many other parts of the world, long-distance travel, inconsistent charging access, and energy cost variability still make full electrification difficult to rely on daily. Mazda's approach fits directly into that gap. It does not try to replace electric vehicles. It tries to make electrification usable in places where pure EV adoption is still not fully realistic. Inside this system, the role of the Rotary engine becomes even more interesting. It is no longer the centerpiece of performance, but rather a highly optimized energy generator. Its job is simple, but critical. Keep producing electricity efficiently without disrupting the driving experience. By operating at steady speeds and controlled load conditions, it avoids the inefficiencies that traditional engines face in stop-and-go environments. This allows the electric motor to remain the true source of motion, preserving the smoothness and instant response that drivers expect from modern electric vehicles. Meanwhile, the electric motor itself carries most of the driving responsibility. It delivers instant torque from a standstill, maintains smooth acceleration across speeds, and eliminates the mechanical hesitation associated with traditional transmissions. From the driver's perspective, the experience feels almost indistinguishable from a fully electric vehicle. The only difference is what happens behind the scenes, where the rotary generator quietly ensures that energy is always available when needed. This dual-layer system also changes how drivers think about long-distance travel. Instead of planning trips around charging stops, the vehicle allows a more flexible approach. Fuel becomes a secondary energy source rather than the primary driving force. Electricity remains the main medium of motion, but it is no longer limited by plug-in dependency alone. This combination reduces one of the most common psychological barriers to EV adoption, range anxiety, at the same time. Companies like Tesla continue to push aggressively in a different direction, focusing on expanding high-speed charging networks and improving battery density. BYD is also advancing rapidly, integrating vertical control of batteries and vehicles to strengthen its EV ecosystem. These companies are not slowing down. If anything, they are accelerating, which is why alternative approach does not replace the current direction. It simply introduces another layer of competition in how that future might be reached. What makes this moment particularly important is the timing. The automotive industry is still in a transition phase. No single technology has fully replaced the other yet. Internal combustion is declining, but still dominant in many regions. Electric vehicles are growing, but still dependent on infrastructure expansion. Hybrids, once seen as temporary solutions, are now re-emerging as serious long-term strategies. In this environment, Mazda's system is not an outlier. It's part of a broader reevaluation of what transition actually means. From a manufacturing perspective, this also has major implications. Range extender systems potentially require smaller batteries than full EVs, which can reduce cost, weight, and material dependency. That could make electrified vehicles more accessible in price-sensitive markets. It also reduces pressure on rare material supply chains, which have become a growing concern in large-scale battery production. These factors do not make the system superior or inferior to full EVs. They simply make it differently positioned within the ecosystem. As the industry continues to evolve, one thing becomes clear: the future of mobility is unlikely to belong to a single technology. Instead, it will likely be shaped by multiple overlapping solutions, each optimized for different regions, needs, and stages of infrastructure development. Full EVs, plug-in hybrids,